Good morning, class. Today we are continuing to talk about rate. Happy Monday. Welcome, and let's get started. So, I want to continue to show you guys about line diagrams and also introduce to you a few new things, okay? So we're going to do that by looking at this question first, okay? And this is a fairly simple question. I'm sure you guys can just figure it out in your heads right away, but I want to use it to show you a couple things about how we can represent rate, okay? So let's look at this. Anna makes $5 an hour babysitting. How much does she make in 3 hours? So with our line diagram, we can mark our spots, and we know that 1 hour is $5, okay? And it's asking us to find out how much she makes after 3 hours, okay? So that's how we represent it, and the number of dollars in 1 hour equals 5, right? Okay, but here's the catch. So the way that I wrote it right now, okay, and here, let's finish this off. The number of dollars in 3 hours, we know, will be 5 times 3 hours, which is 15. Okay? But here's the catch. We don't want to actually use the equal sign because these are two different things. Hours and dollars aren't the same, right? That's why it's a rate. Okay? They're different measurement units. So to use the equal sign isn't quite accurate. It's not what we want to do. So instead, what I want you to do when you're representing it this way is you can write 1 hour and draw yourself an arrow, okay? Because this will tell us that 1 hour is worth or is $5, okay? And then 3 hours is, we'll draw our arrow sign, and then we do our 5 times 3. And of course, because this is an equation, we can do an equal sign. And then we have our $15. Okay? So you see how that works? And once you even have these arrows in place, you can help yourself out by drawing arrows down as well. Because you know that to get from 1 hour to 3 hours, you have to multiply by 3. Okay? So drawing this arrow will help you remember that you have to multiply this side by 3, which means you're multiplying this side by 3. Okay? Which, of course, we do see that here in this times 3. But just showing your down arrow to get from here to here will help you keep track of things. Okay? So when we continue to work on rate, I want us to continue to use arrows to show what it's worth. And you'll see that actually in this anchor chart. Do you see how I've given arrows there to show the value of the different quantities, okay? Because that's the relationship that they have with one another, okay? And also, because we're given 2 values for the hours, we're told what 1 hour is worth, and we're asked to find 3 hours, the hours are on the left side, okay? So that's important to keep track of as well, because we have all the information we need on this side. So we'll keep hours on the left and put what we're finding, which is the $15 on the right. Okay? So now let's look at our second example. And this one is probably a little less clear to do in your head. So that will help us to see what it looks like with our line diagram and with our arrows. Okay? Okay. So this question is actually the question that is used for your anchor chart with the soda cans, okay? So you can see it all laid out there for you, and I'm just gonna write it out here now, okay? So we're gonna start with our line diagram again, okay? And this time, we're told a machine makes 1,800 cans of soda pop in 1 day, which is 24 hours. How many cans does it make in 1 hour? Okay, so we know that the information we can fill in is going to be on this side because it's 24 hours. Okay, and we're looking to find 1 hour. Okay, and we know that we have 1,800 cans after 24 hours, which means that this is our gap to find the rate for 1 hour. Okay? So when we're doing our little arrows, we're going to put hours here, 24 hours, because we know that the value that we're looking for, or that we have, is hours. Okay? And here's my arrow for 1,800. Okay? And 1 hour then is 1,800 over 24. Because we're going down to find the unit rate, we have to divide. Okay? 1,800 by 24, which equals, okay, and we can do our equal sign because it's an equation, 75 cans. So remember that we can draw our division, because that's what's happening here, using our fraction line, and that'll help us. Okay? So there are those two examples. Now I'm going to write 2 more examples up on the board for you, so hang tight. All right, so let's have a look at this example. And this is probably another example that you can do in your head. It's fairly simple, but I do want to show you how we can use the skills that we're working on in this question. So this question says that water drips from a tap at a rate of 2 liters per minute. Okay, how long will it take for 12 liters to drip out? Okay, so let's start by drawing our line diagram. Okay, so we've got our 2 points that we're comparing. And the known information is that there's 2 liters for 1 minute. Okay, and it's asking us how long will it take for 12 liters to drip out. Okay, so because we have 2 values for liters, we're going to put liters on the left side. Okay, and that's going to determine the value of minutes. So we know this relationship already is 2 liters for 1 minute. Okay, and what we are going to do is find the value of 1 liter, okay, because by finding the value of 1 liter, we can find the value of any amount of liters, like 12, okay, and to get from 2 to 1, we divide it in half, okay, or we have to divide by 2, so it's represented as 1 over 2, so half a minute, okay. And that's the place we need to get to because this is the rate of the number of minutes per 1 liter. Okay? So this way we divided. Okay? And now that we have that, we can go to 12 liters. Okay? And to find 12 liters, we know that we have to multiply by this. So we're going to go half times 12, which equals 6. Okay? And to get from here to here, we times it by 12. Okay? So you can again see the relationship of getting from each spot to each spot. Okay? So we know that it will take 6 minutes for 12 liters to drip out. Okay? And this question, because it's simpler, we can see that 12 is 6 times the value of 2. So another way that you could do it is to just multiply our 2 by 6. Okay? Okay, and so that's probably what you did in your head, but that's a relatively simple question. And it might not always be as clear to see that that's the difference between the 2 amounts. Okay, for example, our next question involves numbers that are a bit bigger. Okay, so let's have a look here. So, a photocopier can print 24 pages per minute. How long does it take to print 2,064 pages? Okay, so again, we want to start with our line diagram because that just is a really great way of representing what information we have. It just organizes it so we can see. Okay, so let's put pages here. And we know there's 24 per 1 minute. Okay, and it's given us the second value as 2,064 pages. Okay, and it's asking us how long that would take. So again, the value that we have 2 of is pages. So we're going to put the 24 on the left side of the arrow. Okay, and the relationship that we know is that 24 pages are made in 1 minute. Okay, so that's what our arrow is going to look like. And we still need to find out the value of how long it takes to make 1 page. Okay, because then we can find out how long it takes to make any number of pages. Okay, and in order to do that, we have to do 1 over 24. Okay, and so instead of having 24 pages per minute, we're saying that it takes 1/24 of a minute per page. Okay, so you see how the value, the emphasis is switched, right? The relationship focuses on how much time it's taken per page, okay? And it's 1/24 of a minute, okay? So now that we have this information, we can find the value of 2,064 pages, okay? Which we're gonna do by multiplying, right? So we have 1 over 24 times 2,064. And we know that when we're multiplying with our fractions, we're multiplying it with the top. So it will become, and I'm just going to put this over here to the side, 2,064 over 24, which you'll then have to simplify to become 86 minutes. Okay, so our final answer is that it takes 86 minutes to print 2,064 pages. Okay, so do you see how that works? So it's important to find the value of 1 for the known values that we have in order to find the second value of what's missing. Okay, so we're starting by dividing down and then we're multiplying back up. Okay, so this is similar to some of the word problems we've even seen before where we're aiming to find what 1 unit is worth, right? So we've kind of seen this before, but now we're looking at it in a new way because we're looking at rate. Okay, so now that we've seen a couple of my examples, we're going to take a peek into our textbook. So I want you to take a minute and turn to page 46 in your textbooks, okay? Let's look at our examples here. So number 5 says water is flowing from a tap at the rate of 25 gallons per minute. So A is asking us how much water can be collected from the tap in 5 minutes. Okay? So just like the little thought bubble has, we're going to start with our line diagram. Okay, so we have 25 gallons per 1 minute. And it's asking us how many gallons will come in 5 minutes. Okay, so that's what our line diagram looks like. And when we draw the arrows, we're putting minutes on this side because that's what we have 2 values of already. Okay, so 1 minute is 25 gallons. Okay, so this is easy because all we have to do, because we already have 1 on the left, in order to get to 5, we know that we're multiplying by 5. So we have to do 25 times 5, okay, which is going to bring us to 125 gallons. So 125 gallons can be poured out in 5 minutes, okay? But now let's have a look at B. B is switching it up for us. It says, how long will it take to fill a container of a capacity 100 gallons? So this time we have to switch things around because it's not in 5 minutes anymore. This time we're given the second set of information for gallons, okay? So it's asking us how long it will take for 100 gallons to be poured out. And this is our question. So this time, the gallon value is going to be on the left. So we're starting with 25 gallons is worth 1 minute. There's 25 gallons per 1 minute, okay? And so we need to find the value of how long it takes 1 gallon to be poured out. Okay, and to find this, we know we have to divide. So we're going to represent it as a fraction, 1 over 25. Okay, so this is the amount of minutes per gallon. Okay, and it's 1/25 of a minute per gallon. Okay, and now that we have that information, we have what we need to find how long it takes. 100 gallons. Okay, and in order to find that, we're doing 1 over 25 times 100. Okay, which we know with our fraction work is going to look like 100 over 25 first, and that's going to bring us to 4 minutes. So our answer is that it takes 4 minutes to fill the container. Okay? So the important thing to recognize is that when you're given two values of something, so 25 gallons and 100 gallons, that needs to go on the left because that's going to determine how you find the missing value, which in this case was the minutes. Okay? So again, we divided down to get to 1, and we just represented that as a fraction. And then from there, we can multiply up to 100. Okay? So now let's look at the last example and then I will let you go. Okay? So this is question number 6 in the textbook. So it says Mrs. Ricci types 45 words per minute. At this rate, how long will she take to type 135 words? So again, we're going to start with our line diagram. And we know that we have 45 words for 1 minute. Okay? And it's asking us how long it will take her to type 135 words. So this is our question. This is a value we don't know yet. So because we have two values for words, it goes on the left. So 45, the relationship we know is 1 minute for 45 words. Okay, so we need to find the value of 1 word. And we're going to represent that as a fraction because it's 1 divided by 45. Okay, that's how we get down there. We're dividing down. And now that we have that, we can see how long it takes to type 135 words. And we know that to do that, we have to multiply. Okay, and we know that that's going to look like, I'll just draw a line so we're not confusing. 135 over 45, which simplifies down to 3. Okay, it takes her 3 minutes to type 135 words. Okay, so I hope you see how that works. I think line diagrams are helpful to organize the information that you're given, and arrows are important so we also know the relationships that we have and the relationships that we're aiming for. Okay? So when you're working in your workbook, please make sure that you're using these tools to help represent the rates that you're working on. Okay? So now it is your turn. Please open up your workbooks and you're doing exercise 33. Okay, which is on page 55 and 56. This one is 2 pages, okay? So please make sure that you're showing your line diagram as well as using arrows to show the relationship between the information that you're given between the two quantities, okay? And as always, let me know if you have any questions. You can always reach out to me, okay?